Okay, so we are doing question number 5, I believe is the one that I had given to you. 1, 2, 3, and 5. Okay, so we're doing number 5. So number 5, suppose a diverging lens. Okay, so we've switched. 1, 2, and 3 were all converging lenses. Now we're dealing with the diverging lens. Suppose a diverging lens has a focal length of 10 centimeters and object height 1 centimeter placed in front of the lens at 10 centimeters. Locate the resulting image. So let's write out our knowns. Known. What's known? Known is F equals 10 centimeters. Oh, sorry, guys. I'll just scoot that back. Scoot, scoot, scoot. There we go. So known. F equals 10 centimeters. All right. We then have object height is 1 centimeter. We then have object distance. Our dou is 10 centimeters. And then we are looking for di. Just to remember, though, I didn't write it on the last one, but this is a diverging lens, okay? So diverging lens, remember, it is different when we place the object at the focal length. See how it's at the focal length? When it's diverging, it's different than when it's converging. When it's converging and we place it at the focal length, there is no image. That doesn't work with diverging, okay? Diverging, this is the one where we always get the virtual images no matter where you place the object, okay? So let's find out where the image is, okay? So let's start with our formula. 1 over F equals 1 over di plus 1 over dou. Just to get into a good habit, I'm going to isolate for di first because that's what I usually always do. So we have to get rid of the 1 over dou. It's a positive. So what are we going to do? We're going to take it away. Whatever you do to one side, you have to do to the other. So we are going to do that. And now we have it isolated. So now we can fill it in. Okay, I'm just going to scoot this down. So 1 over 10 centimeters minus 1 over 10 centimeters, 1 over di. And you know what I did? And I did it. See, this is good because I made a mistake. I didn't make a mistake yet. But I noticed that I forgot to put something in. So because this is a diverging lens, all right, diverging lenses always have F as a negative. So I didn't. So this is good. See, I always make mistakes. I forget things. F has to be negative. So this should have been a negative, all right, which means that this should have been a negative, that this is a negative, and that this is a negative. Okay, so because it's a diverging lens, for diverging lenses, the focal length is always a negative. Okay, and that's because we're dealing mostly with the focal length that's on the same side as opposed to with converging that always deals with the focal length that's on the other side. So I had forgotten that. So I've now put the negatives in here. Okay, so now we'll get the right answer. Sorry, that's my mistake. And sometimes I make mistakes and I forget the little things, and that's okay. All right, so now that we have it correctly written out, we have negative 1 over 10 centimeters. Take away 1 over 10 centimeters, 1 over di. All right, so now we're going to end up with 2 over 10 centimeters equals 1 over di. So now we're going to cross multiply. So the negative 2 di equals 10 centimeters. We need to get rid of that negative 2. Oh, sorry, guys. Didn't put all that way. So we have negative 2 di here. So we need to now divide the negative 2 out. Remember, opposite operation, because this is a multiply. We need to divide it out to get rid of it. Whatever you do to one side, you have to do to the other. So we're going to end up with a distance image of negative 5 centimeters, okay? And because this is a diverging lens and you only get virtual images, remember, di must be negative for virtual images. Well, we got a negative answer, which means we did it correctly, okay? So the distance of the image is going to be negative 5 centimeters. So it's going to be on the same side as the object, okay? And that is question number 5.